today we will be converting fractions to decimals. Go ahead and write to convert fractions into decimals and page 6. Now this skill is very important for this year, so it's really important that you get this down. Okay, first of all, when I'm looking at my place value, I need to know place value. Okay, here's my decimal. Anything to the left of the decimal are whole numbers. Anything to the right are fractions or parts. So go ahead and label that. All right, and we have the ones, the tens, the hundreds, it continues on, tens, hundreds, thousands, 10,000s, etc. Okay, so, but these are the ones we'll probably use the most often. Now, one way you can convert a fraction into a decimal is by using the power of 10, meaning 10, 100, 1,000, 10,000, etc. Because a decimal, it's a base 10 unit, so tens, hundreds, thousands. So if you can get your fraction to make an equivalent fraction with a denominator of 10, 100, 1,000, etc., then it's really easy to write your decimal. So for example, 1/4, I can't get 4 to 10 because 4 times 2 is 8 and then skips to 12, but I can go to 100 because I know there's 4 quarters in a dollar. So this I could do times 25. Well, remember, whatever I do to 1, I need to do the same thing to the numerator. So times 25, and 1 times 25 is 25. So this would be 25 hundredths. Well, if I know that the fraction is 25 hundredths, I can just put a 25 that ends in the hundredths place, which would look like 0.25 or 25 hundredths. Now, this is really good, in fact, only can be used if your denominator is a factor of 10, 100, 1,000, okay? Must be a factor of 10, 100, 1,000, etc. Okay? So for example, I'm going to quickly just show you an example of one that this would not work for. Let's say I had 1/3. Well, if I was trying to make an equivalent fraction, that means I need 10 or 100 or 1,000 or something like that, a power of 10, to be my denominator. Well, I can't get 3 to 10, so that's not going to work. 3 times nothing gives me 100. 3 times nothing gives me 1,000. There's no power of 10 that I can put right here and actually get 3 to go to it. So this is never going to work if I use this strategy, okay? So this is really great on things, for example, if you have a denominator of 2, 4, 5, 10, 20, 25, 50. Those are really easy to get to 100 or to 10 or 1,000, etc. Okay? But if you have weird numbers like 3, 6, 9, those are not going to work for this. So I'm going to show you a method that does work. And you can just convert by dividing. Now, even though this only works with some fractions, dividing works with all fractions. So I recommend you use this strategy, at least know it. You can get by without knowing this. You cannot get by without knowing this, okay? So, starting off, remember ice cream cone? My numerator is the ice cream, and my denominator is the cone. Because this is the ice cream, I put my division line and I put the 1 on the inside. So I've already worked it out for you here, and I'm going to work it out again right here just to kind of show you step by step what I did. And I would recommend you also do this. So the 1 I put here, the 4 goes here. Now when I'm dividing, 4 does not go into 1. So it goes in 0 times. Okay, so what I'm going to do is I'm going to add a decimal, and if I add a decimal here, I have to also put 1 in my answer, in the quotient, and then I add a 0, okay, because 1 and 1.0 are still the same number, so I haven't changed the number, okay. Now, I'm going to see how many times 4 goes into 10. Well, 4, 8, that would be twice. Then I multiply, 4 times 2 is 8. I subtract. 10 minus 8 is 2. And you can show this to borrow, okay? Now I have a remainder. Again, I can't stop until I get 0 as my remainder. So what do? I add another 0. No need to add another decimal. You can't have more than 1. You already have a decimal here. Again, 1 and 1.0 and 1.00, all the same number. So I haven't changed anything. Now I can bring this 0 down. 4 goes into 20 5 times, which is 20. And now I'm done because I have 0 as my remainder. So here's another way to show that 1/4 would give me 25 hundredths, or 0.25. Okay, again, same fraction, 2 different methods to get to my answer. Pick which one works for you. All right, next one. Sometimes when you divide, you're going to get a repeating decimal. In fact, if you have a denominator that's a multiple of 3, 6, 9, 12, 15, chances are you're probably going to get a repeating decimal, unless it can be further reduced. Okay, so we're going to go ahead and use our dividing method to work this one out. This is my ice cream. So 2 is going to go in the freezer. The 9 is going to go outside. All right, 9 does not go into 2 because 9's bigger. So that's a 0. I put a decimal, and I add a 0 in my dividend. Okay, now 9 goes into 20. Well, 9, 18, so that's twice. I subtract. 10 minus 8 is 2. Well, I still have a remainder, so I can add another 0. I bring it down, and I got 20. Again, I had 20 here, now I have 20 again. Well, that means it's going to go in twice, which is 18. And now look, I'm subtracting 18 again, which means I'm going to get 2. And you can see that this pattern will go on forever and will never stop. So there's no need for me to keep going because I know it's going to repeat. So the way for me to show that this is the decimal that's just repeating, it's going to go 2, 2, 2, 2, 2, 2, 2, 2, 2 forever. I can just put a line over the 2, over both of them if I want, and show that this is a repeating decimal. Now, really quick, if I stopped and put 0.2 with a line, that's the same thing as putting 0.22 with a line, or 0.222, okay? Any of these are great as your answer. They all mean the same thing. So it doesn't matter how many 2's I put, as long as I make sure I put that repeating sign to show that it's 2 going on forever. Okay? Next one, sometimes we're going to have an improper fraction. Guess what? It doesn't matter. We do the same thing. We just divide. Okay? So, ice cream. Why don't you go ahead and start dividing on your own, and then we'll see how you did. Now, this time, since it's improper, that means it is going to go in. So don't get in the habit of putting 0 point every time you divide. Sometimes, especially if you have improper or mixed number, you have a whole, so you're going to have a whole number, okay? So 3 doesn't go into 1, but it does go into 19. So 3 times 6 is 18. I subtract, and I get 1. Well, now I have a remainder. So here's where I would put my decimal and add a 0. I bring this down, and I can keep dividing. 3 goes into 10 3 times, which is 9. I subtract. 10 minus 9 is 1. Well, hopefully you can see that this would continue on. I have 10 again, so it's going to go in 3 times. So I can stop because I already know that this 3 is repeating. So my answer is 6.3 repeating, or 6.33 repeating, etc. All right. And last one, if I have a mixed number and I want to make it into a decimal, well, this is actually, I think, a little easier. I don't have to worry about this 4. If this is a whole number here, it's still going to be a whole number in my decimal. So I'm going to go ahead and just put 4 point something, okay, because it's still going to be a whole number. All right, so then all I have to worry about is the 3/5. Ice cream. I'm just going to divide the fractional part. So 3 goes on the inside and the 5 goes on the outside. Go ahead and divide that. 5 does not go in, I put a 0. I add my decimal and a 0. 5 goes into 30 6 times, which is 30. And that gives me 0 as my remainder, so I'm done. So now, this 0 doesn't really count because I actually do have a whole number. I have 4. So I basically just need to put them together. This would be 4.6 as my answer. All right. Keep practicing your division, and I'll see you next time.